It's pretty amazing how many of us are fascinated by the world of tech, even if, we don't spend our days coding.
Yeah, for sure.
Especially AI, right? Like you see these big advancements and it's kind of like trying to follow a movie's plot,
Yeah.
but you miss the first half, you know what I mean?
Yeah.
So today, we're going to unlock some of that mystery,
Right.
and we're going to take a deep dive into something really cutting edge in AI.
Absolutely.
But we're going to do it in a way that makes sense, even if you don't live and breathe tech,
Yeah,
right?
no tech dictionary needed.
Exactly.
So today we're focusing on DeepSeek R1. These are a new set of AI models from DeepSeek AI. And what's interesting is how good they are at reasoning.
And for this deep dive, we're going right to the source.
Right to the source.
We've got DeepSeek AI's research paper,
Yeah.
the one that lays out exactly how they built these models and then how they put them to the test.
Yeah.
So you're getting a firsthand look here,
Yep.
straight from the research. And our goal today is simple.
Mhm.
We want to pull out the most important and interesting things about DeepSeek R1, focusing on what could be a big deal for anyone, watching the tech world.
Yeah.
And we're going to make sure we get the main ideas without getting lost in all the, super technical stuff.
Exactly. Keep it nice and straightforward.
Okay, so the paper really emphasizes this reasoning capability.
Yeah.
Now, for those of us who don't think in algorithms, why is that such a big deal?
Well, imagine you've got like a complex puzzle, and you're trying to solve it.
Mhm.
One way is just to try fitting the pieces together randomly until something works.
Right.
But reasoning is more like you actually look at the shapes, the patterns, think about where each piece should go logically.
So it's not just trial and error.
Exactly.
Okay.
So in AI, reasoning is kind of similar. It's the ability to process information,
Hmm.
understand the relationships between those pieces of information,
Okay.
and then use that understanding to solve problems or make decisions logically step by step.
So it's not just remembering a bunch of facts.
No.
It's about like connecting them and then using them to figure things out.
Exactly, yeah, in new situations even.
That makes sense.
And that's where it gets really interesting. This
Yeah.
whole thing about reasoning, it's seen as a big step towards something called AGI, artificial general intelligence.
Okay, so AGI, is that the idea of an AI that's basically intelligent like a human?
Yeah,
Like it can do a lot of different things, not just one specific thing.
precisely. Yeah. So it's like moving from a specialist AI that can, win at chess every time to something much more adaptable.
Right, more general purpose.
Exactly, can learn across different fields. And these improvements in reasoning in models like DeepSeek R1, it suggests we're actually moving in that direction.
So moving beyond the AI that's just good at one thing.
Exactly.
So how did they actually build this better reasoning into these models?
Well, they did something quite interesting.
Yeah.
The paper mentions two main ones, DeepSeek R10 and then just DeepSeek R1. What makes them different?
That's a great question. So what is it?
So DeepSeek R10 was the experimental one,
Okay.
and the idea was to train it mainly through what's called reinforcement learning,
Okay.
or RL. And the cool thing is they didn't feed it tons of pre-existing examples of how to reason.
So it was figuring it out on its own, kind of.
In a way, yeah.
Okay, so reinforcement learning, for someone who's hearing this for the first time, what does that even mean?
Well, think of it this way.
Yeah.
You're teaching a dog, to navigate a maze. You
Mm,
don't give it like a map.
right.
You reward it when it gets closer to the exit and maybe a little penalty when it bumps into a wall.
Hmm.
Over time, through trial and error and rewards, the dog learns the best path.
Okay, makes sense.
That's the idea behind reinforcement learning. With DeepSeek R10, they basically rewarded the AI when it got the right answer and, did it in a specific way.
So it was learning by doing and getting these digital pats on the head when
Yeah.
it solved a problem. So what happened? Like, what were the results of this whole learn by yourself approach?
The results were surprising. DeepSeek R10 really did develop strong reasoning abilities.
Wow.
But here's the really interesting part. It seemed to figure out strategies on its own. Things like self-verification, almost as if it was checking its own work. And even something like reflection, where it would reconsider its approach, if it wasn't getting the answer it wanted.
So the AI is having a moment of, hold on, let me think about this again.
Yeah, pretty much.
That's crazy. Can you give an example of what this self-verification thing might look like?
Sure. Imagine It's trying to solve a logic puzzle.
Yeah.
It gets to a possible answer,
Uh-huh.
but then it goes back and checks each step it took, like a detective reviewing their clues.
Right.
If it finds a mistake in its logic, it changes the answer.
It's like double-checking its work.
Yeah, exactly.
Wow.
So without being specifically taught how to reason, it started to figure out these techniques through just trial and error.
That's wild. The paper even talked about like an aha moment during the training. What was that about?
This was something the researchers observed during training, and it was really fascinating.
Yeah.
They noticed that DeepSeek R10 started spending more time on problems it figured out were harder.
Oh, interesting.
It's as if it recognized that, hey, this one needs more attention.
Right. It knew it had to focus.
And it even seemed to reevaluate its initial approach when it came up against a really tough problem.
It's almost like watching a student go, okay, this is going to take a little more effort.
Yeah, exactly. Like it's changing gears.
That's so cool. But the paper also mentions some issues, especially with how DeepSeek R10 kind of presented its reasoning, right?
Yeah, that was a key thing.
Okay.
So while it was great at reasoning, its explanations weren't always easy for us to understand.
Right.
It would mix up languages sometimes, or its answers weren't structured in a way that was easy to read.
Got it.
And that's where the second model, DeepSeek R1, comes in.
Okay, so DeepSeek R1, this was designed to fix those communication problems.
Basically, yeah.
So how was the training different?
The main thing is DeepSeek R1 got a little bit of a head start.
Okay.
Before the whole reinforcement learning process, it was trained on a small but super carefully chosen set of data. They called it cold start data.
So what was in this cold start data?
It was mainly long, detailed examples of something called chain of thought reasoning.
Chain of thought. Yep.
Think of it like step-by-step guides,
Yeah.
showing how to break down and solve a problem
Right.
with each step clearly laid out.
Okay.
But here's the key. Humans were involved in making this data to make sure it was easy to read and understand.
So it's learning from really good examples of human reasoning.
Exactly.
That's pretty cool. So it learns from these human examples, and then it keeps getting better with that reinforcement learning.
Yeah.
What were the advantages of doing it that way?
The biggest thing was the readability. DeepSeek R1 started producing answers that were much easier to follow and understand.
Right.
Its summaries were clearer, too. And by starting with this base of high-quality reasoning, it might have even boosted its problem-solving performance.
That makes sense.
Yeah.
And the training process for DeepSeek R1, it was more involved than just reinforcement learning, right?
Yeah, there were a few stages.
Okay.
It started with that cold start fine-tuning on the chain of thought data.
Right.
Then it went through reasoning-focused reinforcement learning, kind of like DeepSeek R10. But then they use a trick called rejection sampling,
Okay.
which is a way for the AI to generate lots of possible answers and pick the best one.
Interesting.
And they combined that with more supervised fine-tuning, using all sorts of different data, like writing tasks, question answering.
So it's learning from a lot of different sources.
Exactly. And then the final stage was more reinforcement learning.
Okay.
But this time, to make sure it wasn't just smart, it was also helpful and safe to use.
So the big question is, how well does it actually work?
Yeah.
The paper mentions these benchmarks. What are those in simple terms, and how did DeepSeek R1 do?
Benchmarks are like standardized tests for AI.
Got it.
They're a way to compare different AI systems fairly. This paper highlights DeepSeek R1's performance on benchmarks that specifically test reasoning.
Okay, so can you give me an example of one of these reasoning tests that DeepSeek R1 took?
Sure, one is called AMY. It's a tough math competition for high schoolers.
Yeah.
It takes a lot of logical thinking to do well.
Yeah.
Another one is Code Forces, which is all about competitive programming,
Right.
testing how good you are at algorithms and coding under pressure.
These are hard for people too, right?
Definitely.
So how did DeepSeek R1 do compared to other AIs and even, human experts?
On AIM, DeepSeek R1 scored similar to some of OpenAI's models in the O1 series.
Okay.
The ones that are known for their reasoning.
Yeah.
But get this, on Code Forces, it performed at an expert level. It actually beat over 96% of human participants.
Wow, that's impressive.
It really shows how far its reasoning abilities have come.
So it's not just a math and coding whiz.
Nope.
It's got broader knowledge too.
Oh, yeah. It did well on general knowledge tests and in understanding long pieces of text, which is a big deal for a lot of real-world uses.
Right, like processing tons of information.
Exactly.
Were there any areas where they said, hey, this still needs work?
Yeah, the researchers were pretty honest.
Good.
For instance, because of their safety protocols, the model wasn't as good on certain tasks in Chinese,
Okay.
and they had limited data for really complex software engineering, so it didn't improve as much in that area.
Makes sense.
It's good to see that kind of transparency.
Absolutely. Now, something else I found interesting was distillation. What is that in the world of AI?
Okay, imagine you've got a master craftsman who's amazing at their craft,
Yeah.
and they pass on their skills and secrets to an apprentice.
Right.
Distillation in AI is kind of like that. It's taking a huge, super capable AI model and transferring its knowledge to a smaller one.
So it's like packing all that smarts into a more manageable size.
Exactly.
What's the advantage of that?
The main thing is accessibility. Big AI models need a lot of computing power to run.
Sure.
If you can distill their reasoning into smaller models,
Yeah.
it means more people can use it on more devices. It doesn't need as much horsepower.
It's about spreading the AI love, making it more available.
Exactly.
So how did DeepSeek AI do with this whole distillation thing?
They got some really cool results.
Yeah.
They managed to take the knowledge from DeepSeek R1 and put it into a few smaller models.
Yeah.
What's amazing is that even these smaller distilled models beat larger AI models that weren't focused on reasoning.
Really?
For example, their 7B and 32B models outperformed some of the best open source models out there that were much bigger.
So even a relatively small AI can be incredibly powerful thanks to this distillation process.
Yeah, it's like a brain boost.
That's pretty incredible.
Yeah.
The paper also talked about something that I thought was really interesting, which is the comparison between training a smaller model directly with reinforcement learning versus using distillation.
Right, that was an important finding.
What did they learn when they compared those two ways of doing things?
So they did this experiment where they trained a smaller AI called Quen 32B directly with tons of reinforcement learning.
Okay.
And then they compared it to a similar sized model that had learned through distillation from DeepSeek R1.
Yeah.
And the results were super clear. The one that learned through distillation was way better at reasoning.
Oh, wow.
That's a big deal.
So it's better to build up those skills in a larger model and then transfer them down rather than trying to teach a small model from scratch.
It seems that way, yeah.
Right.
It suggests that having that solid base of knowledge and reasoning in the larger model is key.
It's like a mentor-student relationship, right?
Exactly, and distillation is a really valuable tool for making these advances in AI reasoning more widely available.
This has been so interesting. I've learned a lot. So for our listeners out there who are into tech but maybe don't have that super technical background, what's the takeaway here? Why should they care about DeepSeek R1 and this whole idea of improving AI reasoning and then making it more accessible through distillation?
Oh, all of this, while it is technical,
Yeah.
it has the potential to really change a lot of things in our lives. Think about any field where complex problem solving or in-depth analysis is important,
Yeah.
like healthcare, education, even everyday tasks. This could lead to more powerful and helpful tools, like AI that can help doctors with diagnoses or personalize learning for students, or even make virtual assistants way smarter.
It's about smarter AI that can actually help us with all kinds of things, big and small.
Exactly. And because these abilities can be put into smaller models,
Yeah.
this level of intelligence could be in all sorts of devices that we use every day.
That's exciting.
It's a big step towards AI that can understand and reason without needing massive computing power. That's huge.
It is huge. So today's deep dive has been really enlightening. Let's recap the main points. DeepSeek R1, it shows huge progress in AI reasoning. It does that through some new training methods, including learning from scratch, and also learning from those human-guided examples,
Yeah.
and the ability to then take those skills and put them into smaller, more accessible AI models. That's a big deal.
Absolutely. And what's really fascinating to me is how this AI can learn and evolve in ways we don't always expect, even developing its own problem-solving techniques, you know?
Right.
That gives us a whole new perspective on what intelligence could be.
It really does. So here's something for everyone to think about. If AI can learn to reason so well, even showing signs of figuring things out independently, what does that tell us about how we'll tackle tough problems in the future?
That's a great question.
Maybe even how we teach and learn as humans.
Yeah.
How we work with intelligent machines. It's a really exciting time to be following this.
It really is.
Thank you so much for joining us on this deep dive, and we hope you continue to explore the amazing world of AI.
Thanks for having me.
Absolutely.